So today I'll be talking about fairness and bias in NLP systems. And I think this is really important nowadays. I didn't talk about it 3 or 4 years ago, but I do now. And part of the reason why is because like the societal impacts of NLP systems are becoming like much more obvious as we do more, practical applications and things become in use in real world systems. And specifically from the point of view of like engineering sides of NLP systems, if we think about why we want to build a system, usually it's because we have some problem that we would like to be solving. I believe I showed this example early on in the class. And we build an NLP system and that, solves our problem in some way. So in this particular case, the person in the red had a problem of not being able to communicate because they didn't understand the language. But if we build an NLP system that translates for them, they are able to solve this problem. So in the end, engineering style NLP wants to make the world a better place according to some, metric of better. But like exactly how we quantify better is a difficult question, right? So, just to give the example of the scientific information extraction problem we're doing for assignment 2, how do you think this would make the world a better place? Like, it's not going to make the world a better place from the point of view of the system you're building, because we're not going to actually deploy it. But let's say we had a really good system that was actually deployed in the real world. Any ideas?
Paper reading easier.
Make paper reading easier. Yeah. So like essentially, if you're going in and reading papers for whatever reason, like you're doing research or you're building a system and you'd like to know more about them, it could make paper reading easier. And how many people have used something like papers with code? A lot of people here, right? The fact that all of you are raising your hands indicates that this, like scientific information extraction is actually useful in the real world, right? So, however, that's a little bit indirect. Like, what level of, accuracy would make your life better? And so, another way we can think about it is from the point of view of something called utility, which is the total satisfaction received from consuming a good or service. It's an idea from economics. And so probably the fact that everybody is going out of your way and using papers with code, or like at least browsing their site, indicates that it's making your life better in some way, but it's very indirect. Like, let's say you increased the scientific information extraction, like accuracy by 10 points or something like that. How much would that actually make your life better? It's not super clear. So that's a difficult question. I'm going to kind of sidestep that question a little bit in this talk today, but it's something important to be thinking about. But like, assuming that NLP systems are helping people in the world in some way, either through translation or information extraction or something else, unequal allocation of utility leads to issues of fairness. So if, a system is working better for some people than it is working for others, then that's obviously a problem. A very clear example of the problem is if we think about how well NLP systems work for different people. If we think about how well it might work for an American English speaker, I can use a virtual assistant, just using me as a stereotypical example. I can use a virtual assistant. I can use a car navigation system, translate text, benefit from good search technology. However, if you think about somebody who speaks Japanese, they might use the above technology, maybe with fewer features, maybe a bit worse. If you think of somebody who speaks Marshallese, which is kind of a much less widely spoken language from the Marshall Islands, they either don't use the above technology or they're forced to use it in a second language. And if you're using it in a second language and you're a non-native speaker, you're a native speaker with, or even a native speaker different from the training data, you can have issues with pronunciation, mannerisms, etc. So to give some examples, like you might be a native English speaker from a different place in the world, like not the US. And depending on whether you're from the US, you're from Britain, you're from India, you're from Ghana, or something like this, how well it will work for you is going to be very different, despite the fact that it's all, ostensibly the same language. So any questions here? Maybe quite obvious because a lot of people here are using these systems. But if you aren't using systems in your everyday life consciously, you are, of course, because you're using search. But if you're not using it in your everyday life, I encourage you to try to do the same things you do in English, because all of you here are good English speakers in another language, and see how well it works. Like spend a whole day doing all of your searches in Chinese, or doing all of your searches in Hindi or Kannada or something, and see just how inconvenient it would be to you if you were forced to do that. Because I think most people will switch to English if you can't find something in another language, for example. So yeah.
Two of my colleagues once tried to get a trash bin for an experiment, but they didn't know the American word for trash bin. They couldn't find it online.
Okay, so what Bob said is two of his colleagues tried to do find a trash bin for an experiment, but they didn't know the American English word, so they weren't able to find it online.
Dustbin didn't work.
Dustbin doesn't work. Yeah. So to give another example, like anecdote, about 10 years ago, I was working on machine translation between Japanese and English, and I still remember this moment because it was like influential for me. But I was trying to create Japanese English translation systems, and I was like, I was complaining to one of the colleagues that I worked with, like, it seems like the systems are pretty good right now. There's no obvious low-hanging fruit that we could be fixing, and other things like this. And this was before Neural MT, so the systems were a lot worse than they are now. And basically what he said is, we were in Japan at the time, and he said, well, try spending one full day communicating only in English with people in Japan through a speech translation system, and see how far you get. And basically, like, if you actually try to use it from that point of view and become a user yourself, that can really like give you some insights about what doesn't work well. And another thing is, like, I use translation when I need to translate something from Japanese to English. And despite the fact that translation is really good right now, it's definitely not perfect. Like, no matter what, like some like things that you read or impressions you may have by just looking at your blue scores say. So I think that's a good thing to do. And then remember that if you speak Chinese or Japanese or Hindi, you're still one of the privileged ones compared to the marginally speakers. Okay, so there's a bunch of different ways we can categorize the potential harm that's done to people by systems not functioning well. And one example is allocational harms. And what we mean by allocational harms are basically decisions made by a system affect life positively or negatively, and potentially unfairly. Sorry, that should be potentially unfairly. And allocational harms, to give some examples, unfair positive allocation is an NLP system decides who gets a loan or gets accepted to a university, but there's some sort of bias in this system that causes it to make the decision based on criteria other than the ones that it should be making the decision on. So if you think about why somebody should get a loan, like, what do you think is a fair criterion for this? Any ideas? Yeah.
Credit score, their ability to pay it back.
Their credit score and ability to repay it back. Credit score, I think, is a bad idea because, credit score, like, that's just a score, right? It's not like what you're actually aiming for. Their ability to repay it back is probably very close to what I'd be looking for. Any other ideas? Maybe a slight twist on that? I'd say whether they will repay it back or not is probably a better choice. Like, it doesn't matter if you're able to or not, it matters whether you do. So some people might be very able to repay back a loan, but then they don't. And those would be bad people to give a loan to. So that's a good example. Being accepted at a university, that's actually much less clear. Like, what kind of people do you want at a university? There's some subjectivity in that, but anyway, so we can think of like good criteria, then we can think of obviously bad criteria, right? So like, what would be a bad criterion to select somebody for a loan? This should be easy. Yes. Their background. Yeah. So background is basically there, but if we are more like, if we're more explicit, in the US, it's illegal to select based on protected attributes, and protected attributes are things like race, gender, what others? Religion and stuff like that. So that, you know, it's so obviously bad that it's illegal to do so. And, you know, in general, background, I think is better, but you can also be more explicit. So again, another example of unfair negative allocation. Let's say we have an NLP system who's deciding who to arrest because they might be dangerous. Here, number one, that's probably a bad idea in the first place, according to my personal opinion. But you know, there are better criteria, like whether that person is actually going to commit a crime or actually did commit a crime is a good reason to arrest somebody. But a very bad idea for arresting somebody is because Facebook translated good morning incorrectly into attack them. And then somebody actually got arrested for this. So this is an example of where an NLP system is in the loop for giving, you know, in the loop for making a decision about something as consequential as whether somebody gets arrested or not. And, you know, if it fails, then that causes harms. So these are allocational harms. These are where a system is deciding whether to give somebody positive, some sort of positive benefit or negative benefit. Another potential harm is stereotyping. And so this is especially a problem in NLP systems that do some sort of language generation. And when a system reflects harmful societal biases in its output. To give one example, which maybe is relatively benign to other, compared to other recent examples, when translating gender neutral Turkish sentences into English, Google associates he, she pronouns with, or at least at the point when I made these slides, associated he, she pronouns with stereotypical male and female dominated jobs. This is kind of an insidious form of bias, where, you know, essentially you get a translation that reinforces gender stereotypes. Some things that are even worse is if you look at the like output of many dialogue systems, especially if they're not heavily curated, they'll generate things that are just like completely, you know, racist, sexist, ageist, whatever. Yeah. Yeah.
I was learning Turkish in Duolingo.
Yeah.
And they gave the English translations for all of the O-bish, like O-B-I-R. I actually thought O-bish means me until right now.
Okay. So just to repeat the comment, like somebody was learning Turkish on Duolingo, and they gave all of the examples of pronouns as he, and that would make you think that the answer is he, but in fact, the pronoun is neutral, is gender neutral. So that's not even an NLP system. That's just a system that was probably even curated, but it still had this mistake in it. And I should give Google credit for like trying to tackle this problem like seriously. So if you just throw things into a human or into a machine learning system, it will just learn from the data, and you know, whatever it learns from the data, it will spit out at you. But they actually added a kind of like rule-based system on top of this that identified when there wasn't enough information to decide whether it was he or she. and like do post annotation of the output to identify, to basically say this is a, he or she, we can't determine here. So that's an example of how you can like take a machine learning system and build on top of it to try to identify when you shouldn't be making an assumption about gender, for example, beforehand. One of the problems with that is there are cases when it is very obvious, like there are gender non-neutral pronouns or other things like that. So you kind of need to also detect when it is ambiguous, and you should be, hedging your bets. Another interesting thing is biases in human annotation. And this happens when you have a annotation task where how you will make your annotations depends on your demographics, for example. So just to give an example, a toxicity classification is a particularly obvious example where, for example, it's a particularly obvious example where some annotators might annotate something as offensive and other annotators might annotate something as not offensive. So to give the most obvious example, there are certain, terms that might be considered very racist if somebody from one demographic group uses them, but would not be considered racist if they're used as terms of affection between, people of an in-group. So in order to do this, you both need to understand who is making the utterance, and you might need to be a member of the in-group. Otherwise, like, for example, if somebody of the out-group does the annotation, they might incorrectly think it's something that's very offensive to say. Yeah.
There's a thing online where someone who is not American was asking how to learn how to speak Black English. And everyone just said, don't.
Yeah.
Don't.
So what Bob said is there was an example of somebody online asking, like, what are the terms that I should be using in African-American English? And the people said, don't do that because that would be a bad idea if you're not a member of the group. So that would be one example. This arises from a combination of possibly underspecified annotation guidelines and the positionality of the annotators themselves, being in the in-group or not in the in-group, and different cultural and social norms. There's actually a very nice paper, which I didn't have time to put in the slides, but you can see this. It's a recent paper by Martin Sapp, who's, as people know, a faculty member here. It's called Annotators with Attitudes, How Annotator Beliefs and Identities Bias Toxic Language Detection. And so they examine a number of different things like racially oriented terms and profanity and other things like this, and how your demographics, how the demographics of the annotators cause different annotations to happen based on that. So that's a nice paper to take a look at. This has real practical consequences, though, because toxicity detection is a very important part of social media nowadays. And I think it's useful to have on social media because basically it allows you to pre-filter or at least pre-flag for human checks when people are saying really toxic things that make your social media platform a bad place to be. But if they are basically enforcing these norms incorrectly on people only from a particular group, then that basically is like enforcing the people to move from their like perfectly fine, like non-toxic way of speaking towards closer to what the majority group uses when they're speaking. And that's essentially, that can be harmful for them. That's like essentially a microaggression against them, saying that your normal way of speaking is toxic, right? Which is like not good. So moving on to what we can do to detect biases in NLP systems, there are some commonly employed techniques. One method is something called association tests. Another thing is analyzing performance measures across groups, and also counterfactual evaluations. So a very famous example of the association test is something called the word embedding association test. And the way it works is as you know, we learn embeddings from co-occurrence statistics. And these can learn things like king minus woman, man plus woman equals queen. And so this is fine. This is kind of like the definition of king and queen, is that a king is a male monarch ruling a country, and a queen is a female monarch ruling the country. So this is fine. But what if the text also encodes stereotypes that we don't want to be essentially influencing our system and causing these allocational harms or other varieties of harms to people? So a bad example of this would be something like doctor minus man plus woman equals nurse. And the reason why this would be a problem is, for example, let's say you deployed a system based on this, and the system tended to recommend doctor jobs to men and nurse jobs to women unfairly, like irrespective of their qualifications. So one way to do this is, or the word embedding association test does this by considering two sets of target words. So for example, programmer, engineer, and nurse, teacher. And these are words that we think shouldn't, be associated with any sort of protected attribute like gender or race or something like this. And then we also have two sets of attribute words. And these attribute words are the protected attribute that we don't want to be influencing our decisions. So our null hypothesis is that there should be no difference between the two sets of the target words in terms of similarity to the two sets of the attribute words. The mathematical formulation of this is basically that X and Y are sets of target words of equal size, and A and B are the two sets of attribute words, where the test statistic is basically saying that the similarity of the various attribute words, or the similarity difference of the attribute words is no different between the similarity difference of the two sets of target words is no different with respect to the attribute words. So basically, we look at the cosine similarity of the input here to of the input to A and the input to B. And so if there's no difference between these two, then basically there's no differentiation between the target words with respect to the similarity with respect to the attribute words. And so then we can do a test, and what we do is we basically do a statistical test that tries to say that there is no significant difference between the two groups. So what we can see here is in word embeddings, there are associative biases in word embeddings. And the graph here is the percentage of the workers in the, so the graph here is basically showing the associations, and we have the percentage of the workers in a particular occupation being women, and the strength of the association of the occupation with female genders. And so what we can see is basically the more associated a particular occupation is, or maybe a better way to say it is, the more associated a particular occupation traditionally has been with people of a certain gender, the more this the embedding similarity is similar as well. And one problem with this is often our data, number one, like if you apply this to a system that is using this to, for example, make recommendations, it literally would be illegal to be biasing based solely on a person's gender. So if the gender is encoded in the word embeddings in some way, then it would be illegal to deploy a system that, used this method to make recommendations. Another problem, kind of, even if you ignore the legality of doing that or not, the associations with gender very well could be outdated. They could be based on outdated data. So it wouldn't even be necessarily a good recommendation either, because gender is it might be overweighting gender based on outdated stereotypes. And to give a good example of this, this is a very good paper that I don't think I cover in my slides, or if I do later, I'll skip it. But So this is an amazing paper. It really was eye-opening for me, but it's like word embeddings quantify 100 years of gender and ethnic stereotypes. I warn you that you probably don't want to read this paper if you don't like reading very ugly, history of the US, basically, where there was lots of racial and gender discrimination. Not saying that there isn't now, but it was a lot worse, 100 years ago. And basically what you can see is that word embeddings that are trained on text from certain time periods basically fairly closely tracks with the racial stereotypes that happened in those time periods. So it's an important thing to think about, if you're training on all of the internet, maybe, all of the internet is not a good representation for what we think is appropriate or in 2022. And you also need to think very carefully about where you're getting your internet data. Are you getting it from uncurated web forums? And if that's the case, then there's a lot of stuff on uncurated web forums that we might not want in our systems, right? So I think this is another important paper to be taking a look at if you're thinking about these topics. And you should be. Cool. Are there any questions here? Or discussion? Okay, I'll move on to the next one. So you can also extend these to sentences. And basically the way you do this is you take a sentence encoder and you get an embedding from it in some way. And once you've gotten the embedding from it in some way, you can use a similar test. And one way they do this is you can slot words into several semantically bleached sentence templates, like this is blank or blank is here. And these sentences are they don't have any bias whatsoever because they're just, stating a fact about the existence of something. And so then you can take the embeddings that you get by running it through your favorite encoder, like, for example, BERT or GPT-3 or whatever else. And because of this, you can then run the same embedding test. One interesting thing is that Elmo and BERT displayed less evidence of association bias compared to older methods, but they still do to some extent. So one issue with these association tests is that they have positive predictive ability, but so they can detect the presence of bias, but it's hard to demonstrate the lack of bias, right? So a lack of evidence of bias is not a lack of bias. So you might detect no bias in word embeddings, but they still might be there. Another issue is even if you did detect bias in word embeddings, it's not necessarily the case that it would propagate to a downstream task. So you might have a recommender system that's based on biased embeddings, but just to give an extreme example, let's say you took the model and then you trained it in a way to reverse the original bias. So you have a list of typically male jobs, a list of typically female jobs, and you train the model to over-recommend jobs from the other that are typically gendered in the opposite way. And in order to compensate for the fact that the underlying system might be biased. And if you did that, you might have biased embeddings, but you might have a system that was biased in the opposite direction, for example. So it could have an effect, but it might also not have an effect. Okay. So another thing is analysis over error rates. And so, as I mentioned before, according to at least US law, and of course, law in many other countries as well, you're not allowed to have systems that have disparate impact. And basically, these are practices that adversely affect one group more than another. And this is something that, number one, we shouldn't be doing. Number two, it opens you up to legal liability if it is happening. And loosely speaking, algorithms exhibit impact disparity when outcomes differ across subgroups. And we can identify this by comparing performance measures across groups. Just to give an example, this is a very nice study in that they didn't actually build a system, but they just used APIs from many different systems that already were online. And basically what they showed was that they examined how well speech recognition worked for speech from groups of white speakers and Black speakers, and basically measured the error rate. And what you can see is, number one, the average word error rate for speakers of like Black English in the US versus speakers of white English was almost 1.5 times as bad. What's even more striking is the best system was worse for Black speakers than the worst system was for white speakers. So there was a bigger effect of what type of English you spoke than what system you were using. So that's pretty striking, I guess. I would say that quite possibly there would be space for a class action lawsuit to sue Microsoft or any of these other providers over this, to be honest. I'm not a lawyer, so don't take me to my word on that. But if you could demonstrate that you were being damaged by the ASR not working well, then you could probably do that. So another thing is that they also even noted that there was a difference by city. And you could see that depending on the population of the city, this also showed up in city level demographics. So you don't even necessarily need to know the demographics of the people using the system. You could even just know something associated with the demographics of the people using the system and could possibly measure this. So like, let's say you would have trouble going out and collecting all this information. You could also measure disparity by location, and that might be a proxy. So this was discussing differences based on what quote unquote language people are speaking. We can also measure it across languages. And these plots are from a paper that I and some co-authors wrote, where basically we examined the disparities across NLP tasks. And the x-axis is the number of speakers who speak each language. And the y-axis is the basically the accuracy of a system. And one interesting thing we can see here is that for things like speech synthesis, machine translation, question answering, there's a pretty big disparity across languages in reported results from many NLP papers. Another very interesting thing you can see is that there's a big white part on the right side of this graph here, and these are languages for which we don't even have a system. We weren't able to find any results for a system trained in that language. So basically what this is saying is, many people who speak these languages wouldn't even be able to use a system, or there was no easily accessible system that we could measure accuracy on here. So basically there's these stark, discrepancies. This is a big problem in NLP. If you're interested in working on this problem, I think it's a really important one to be working on. So that might be something you could consider for your projects. Are there any questions or discussion? Yeah.
Since I can't see the graph, I'm just confused. So on the x-axis is the increasing number of speakers, right?
On the x-axis, so these are sorted by the accuracy. So the accuracy is always decreasing. The width of the x-axis is the number of speakers. So like Chinese would have the biggest, English.
First or second.
Yeah, this is first language. So creating these graphs is a labor in itself, because like, what if you start considering people who speak English fluently as their second language, how much they would probably prefer to use it in their first language if it worked as well as it did in English. So then at what point do they switch over to, preferring English, even though it's not their native language, because English works better and other things like that. So there's a lot of complexity into how you would make these graphs in the first place, but this is considering first language speakers. Yeah. Another thing that we did for machine translation was we measured the importance we measured the demand for machine translation systems based on economic factors. So like, for example, how much trade is there between two countries where these are languages that are widely spoken? And that can tell you, like, there's probably a lot larger need for example, translation between French and German than there would be for translation between French and Thai, for example, just because French, like in Thai and Malay or something like that, because they trade with each other or they interact with each other more. Another thing that you could say is maybe every language is important and we shouldn't be weighting by population in the first place, or if we do, we should be down weighting so that, we don't just focus on the highly populated languages. But yeah, no, I like this paper. So I'll introduce one other thing from this paper. So another thing that we talked about in this paper is what factors impact whether natural language processing research is done on a particular language. And one of the kind of key graphs from the paper is this one. And basically what we did was we plotted the number of language users and the approximate language associated GDP. So this is basically like, if you take the GDP of countries and then you apply it evenly to users of each language, depending on how many people of that language live in that country, how big is the GDP like associated with that language? And then the size of the dots is how many NLP papers there are on that language. And so if you only take things that are approximately equal vertically, you're talking about languages that have approximately the same number of speakers, but differing GDP depending on how high they are on this graph here. And so basically what you can see is you can see that as you go down vertically, even if you control for the number of speakers, the languages with lower per speaker GDP have fewer NLP papers based on them. And basically what this says here is, economic factors are playing a very important role on whether people do NLP work in this language, irrespective of the number of people who are speaking it. And that also doesn't seem very fair to me, right? Like, seems like, it's unfortunately, I think, the way the world works some of the time, but, I would hope that we could be able to provide technology to people, like, based on them being people, as opposed to them, having lots of money to spend. Yeah.
One thing I don't think you mentioned is another factor is that many languages aren't written at all or written very little, which makes it much harder to work with them.
Yeah, so another factor is that languages aren't written very much at all, which makes it harder to work with them. So I think there are definitely a lot of challenges working on languages that don't have, lots of money associated with them. Like, it's harder to get funding to pay for the salaries for people who would be annotating the data or things like this. But I think at the same time, we're now a very decentralized world. We have lots of communication between people, and if something is important, very often you can get people to help out with it. I mean, sure, you should try to pay them if you can, but I feel like the barriers to solving this gap are lower now than they were before. Let me put it that way. So I think that's a problem that we can start tackling. One thing I should mention is I talked about languages here, but the barrier between a language and a dialect is very tenuous. Like, there's a famous saying that a language is a dialect with an army, which is essentially that if you have a country that calls it a language, it gets called a language. If you don't have if there's multiple languages within a country, they're very often called dialects instead. The official definition of a language is when things are not mutually intelligible. So if people are speaking the two languages, you can't understand understand what people are saying if they're speaking the other language. But that's very true for many quote unquote dialects. A lot of the quote unquote dialects in Chinese, you wouldn't be able to understand if you are a speaker of Mandarin Chinese. On the other hand, many languages that are considered like quote unquote languages actually are intelligible by speakers. So like a lot of Portuguese speakers can understand Spanish without, with very little work, or Romanian and Italian and other things like this. So that's another thing to keep in mind when we're talking about this. Cool. Any questions or discussions or? Okay, moving on. Another thing is counterfactual evaluation. And what counterfactual evaluation is this is a method for modifying text by flipping protected attributes and observing differences in model behavior or model performance. And this is particularly useful when you're using a big black box model that you can't really easily go in and probe. So just to give an example of this, this would be like if you're using an online API and you want to probe it for bias and how it makes its decisions. And just to give one example, there's a nice paper on gender bias and co-reference resolution. And they have these, this is called the, I forget if it's called the Winna gender corpus or if it has a different name specifically for the co-reference resolution one. But basically, they introduce a set of minimal pair sentences, much like Winograd schema, where they have the surgeon couldn't operate on his patient, it was his son. And the surgeon couldn't operate on their patient, it was their son. And the surgeon couldn't operate on her patient, it was her son. And basically, if we use the gender specific pronouns, the gender specific pronoun, or we use the kind of like the third person singular there, they is a gender neutral pronoun. In both of these cases, a co-reference resolution system says it is co-referent with surgeon, or basically yeah, it is co-referent with there, which is co-referent with surgeon. But here it says it is co-referent with surgeon and her is co-referent with her, but not co-referent with surgeon. So basically it's saying like, it doesn't think a woman is a surgeon, but it is thinking like men and gender neutral pronouns are surgeons. So this is just one example. And in order to do this, you don't need any internal access to the model. You just need to be able to like measure its performance in some way and flip only the protected attribute to control for all of the other factors that might have to do with accuracy. So this is a good technique. So next, I'd like to talk a little bit about mitigating biases in models. And there are ways to mitigate biases. I don't think any of these is perfect. And I think the only perfect way is to come up, or the only right way is to come up with evaluation metrics to ensure that you're measuring how much bias exists, and then try to mitigate them, try to make sure your evaluation metrics improve until you're satisfied with the amount of bias removal. Hopefully there's no bias. And then if you identify that there still is bias in your system, come up with a new metric that can measure that bias and then optimize your system until it has no bias. But anyway, I'm going to talk about these. So the first one is automatic mitigation. Another one is careful data creation and augmentation strategies and human in the loop strategies. So one method that was previously popular, I think it's a bit less popular now, is trying to learn feature invariant representations. And the way this works is basically you try to learn representations that produce accurate classifications while not being good at identifying protected variables. And this is very similar to methods that I talked about before. In fact, I've shown this slide on the left a couple times in this class. But basically you can take an adversarial learning approach where you train a model that predicts the class label, and you try to optimize the representations of the model so that the class label is predicted accurately. And then you also train an adversarial classifier, where the adversarial classifier is trained to predict the protected attributes, but then you reverse the gradient of the attribute classifier to try to make it so that the features of the model are not, basically make it so it's not possible to predict the protected attribute from the features of the model. And if that's the case, you can essentially it helps remove the bias by making the attributes not obvious from the features. So this is a demonstration of using this specifically with respect to race labels. And you can see that the sentiment accuracy remains relatively high, but the classification of race remains low. However, one problem with this is that even after adversarial training, it's possible to recover the like the protected attributes from the representations that were learned in this way. And basically what you can do is you can just train a model again, or you can train a different model or a better model to try to predict the attributes. And we can see that there's a pretty significant amount of leakage from these representations that even supposedly are like appropriately, appropriately anonymized with respect to the protected attributes. So what I want to say is essentially like, you shouldn't trust this too much. It might be a useful tool to help mitigate biases, but in the end, what you really care about is whether your model is performing well on the task that you want to be doing. So I think downstream evaluation of disparate impact in the final model is probably something you need to be doing, even if you're adopting these approaches. So to give another example, debiasing word embeddings, which could also theoretically be used to debias sentence embeddings if you use the kind of like sentence level word association tests or association tests that I talked about before. So in order to do this, what you can do is you can identify a direction of the embeddings that captures the bias, and then you can neutralize and equalize along this direction or soften the bias that's included in these. So basically what neutralizing means is general neutral words are 0 in the gender subspace. So you identify a space and then identify that words are 0 in the space. Sorry, I thought I had a graph on the slides, but I might have like skipped the slide that had the figure on it. But basically what you do is you if you identify that there are some there's kind of like a direction in which obviously gendered versions of words tend to follow. So like king, queen, there's a vector like this, and then he, she, there's a vector like this. And then like what else? Aunt, uncle, aunt. There's a vector like this. And so basically what you do is you project the all of the word embeddings so that gender neutral words that should be gender neutral have, or gender neutral pairs of words should have a 0 vector for like this line essentially. So they should be equivalent or projected onto the same plane with respect to that line. Another thing is any neutral word is equidistant to all of the words in each equality set. So basically, you would project all of the words so that they would be equivalently distant to all of the gendered words in this set here. And another thing is reducing the difference. When you soften, this reduces the difference between the equality sets while maintaining as much similarity to the original embedding as possible. And these are referred to as soft debiasing. And basically, you can tell, you can evaluate these downstream on things like analogy tests and ensure that essentially, or you can demonstrate that the analogies that shouldn't be gender biased tend to be the same or improve in accuracy, whereas analogies that are gender biased, like ones that you don't want to be gender biased, decrease in accuracy. So one caveat that I should mention here, and I'm sorry, again, I think I don't have the slide here, is I've been talking a lot about like male and female like gender biases, and obviously there's it, especially like it's particularly made a bit more difficult by the fact that a lot of the time there are people who have like non-binary genders or other things like this. I should have a paper reference in the references that discusses this issue and some of the mitigation strategies that people have been doing for that, and I should have included it in the slide deck, but I didn't include it here. So I think that's an important thing to think about as well. So with that caveat, I'm still going to talk about this last slide. And basically what this last slide demonstrated is that even if you, after you do these debiasing methods, it's not, there's still issues with, for example, a supposedly non-gendered word still being closer to socially marked feminine words. So for example, nurse might no longer be closer to explicitly marked feminine words, but it might be closer to other professions that were traditionally female. And so because of this, it's not necessarily the case that this would solve your downstream problem. So this is another this is another argument for being very clear that you're also looking at the downstream system performance with respect to bias, not just the embeddings themselves. Okay, any questions about this part? Okay, so another method that we can use to help solve this problem is using data augmentation methods. And one way to perform data augmentation is to programmatically alter text to invert gender bias and then combine the original and manipulated data. And the idea here is relatively simple. Essentially, you find data that should have, or basically where, for example, if you're talking about gendered pronouns, you could have the doctor ran late because he is late. And if this is typically over-associated with, the word he, you can also add an identical example like the doctor ran late because she is late into your data set and train the model on this augmented data set. And you could also add they or any of the other pronouns that you would like it to handle. And this is particularly useful, like, for example, if we're going to be talking about alternative pronouns that non-binary people like to use for to refer to themselves with. And if that's the case, then these are definitely going to be far underrepresented in the data, and you're going to have issues with handling these. So that would be another way to do it. You could also think about doing it for names, for example, like you might have a bias for people who have non-stereo or names that are underrepresented in the training data that you have. And I don't have the reference directly here, but there have been studies that show that named entity recognition does less well on names from particular ethnicities or genders or particular ethnicities or like basically unusual names in general. But because it does it on I'm not going to say unusual names. Sorry, that's incorrect. Under names that are underrepresented in your training data. And so that's another strong case for data augmentation. So yeah, there's a number of methodologies to do this. It's not quite as important how to use what exactly the methodology is, rather than this is something that you can do, and then you can look at the reference if that's something you want to do yourself. So another example that you can do is augmentation with humans in the loop. And basically the idea of this method here is that you can ask humans to do annotation of your data set so that they flip only the label. Basically you have like for something like text classification, you can ask a human to do annotation of the data set where you flip only, you make minimal modifications to the input to flip the label. So to give an example, this is an example from text classification on reviews. And one of the interesting things, if you just train a text classification model on reviews from the like standard sentiment tree bank, words like romantic get high sentiment and words like horror get low sentiment. And that's just because horror movies tend to have like worse reviews than romantic movies. And so in order to fix this, basically what they did is they asked a whole bunch of crowd workers to modify the input so it changes the label in a minimal way, make a minimal change to the input. So it modifies the label. And after you train a model on this minimally modified data set, you'll notice that these like spurious correlations kind of disappear. So this is also something that you could do for bias mitigation strategies. Okay, any questions about this? Okay, so a final thing is, this is a very, very important topic, but it's a topic that suddenly became very, very popular because of its obvious importance. But I think the research for methodological solutions to the problems actually progressed faster than the research methodology. And what I mean by this is basically like people started coming up with a whole bunch of word embedding debiasing methods, when at that point, it wasn't quite clear that these word embedding debiasing methods didn't actually have a huge effect on like downstream system bias, for example, which is kind of what we care about in the end. And I have this paper as very highly recommended reading on the page for this class. And basically what they do is they survey 146 papers analyzing bias in NLP systems. And what they found was that the motivations behind these papers are often vague, inconsistent, and basically lacking in a motivation for like why you're doing this debiasing in the first place and how it affects people, because that's like what we want to be fixing from the point of view of bias anyway. So another thing is if you're going to be working on bias, there's a lot of work on bias in like philosophy or sociology or other things like this. And I think it would be worth doing a bare minimum of reading of this literature as well. And this paper has quite a few references to that literature. So they make some recommendations. Another thing that I've found from my personal work, I've done a lot of work on multilingual natural language processing. And as a PhD student, I would like to say that I was doing things all wrong. So like I myself have lived and learned from my mistakes on working on multilingual NLP. And basically the biggest mistake that I made was not talking with people who, were who wanted to use the systems or were speaking various different languages. And just to give some concrete examples of how I made mistakes with respect to this, I would hypothesize something very cool algorithmically would be useful to people, when in fact, that's not what they wanted at all. So like I had a a method for learning dictionaries from speech and text without any supervision, which I thought was very cool algorithmically. But when I went to and talked to people and said, how could you use this? They said, well, we just really need a normal speech recognition system. Could you build one of those for us? And that would have been a lot easier than doing this paper on unsupervised dictionary induction. So that's, just talking a little bit to people is very useful. And so that's the final thing here, engaging with lived experiences of members of communities affected by NLP systems. Another thing is providing explicit statements of why system behaviors are harmful and in what ways and to whom. And this, thinking about this will actually guide you to the most important questions in, systems and how you can reduce their bias. And even if you're not working in bias, I think this is a really important thing to think about. And recently in NLP conferences, they often have a required like ethics section or a required limitation section. For my personal experience, unfortunately, this section often gets written last, right before the deadline, which isn't how it has to be. But if you don't make a conscious effort to engage with this early, you might not be thinking about it carefully. And so I would kind of encourage people to think about it a little bit. Think about it early and like, what are the potential positive effects of your system? Who would it be helping? What are the potential negative effects of your system and who could it be hurting? And, if you think about that, even for a little while, I think you can, number one, write a very strong ethics section to your paper. And number two, maybe be building something that's a little bit more useful than if you didn't think about that carefully. So about harms, well-intentioned works can have dual impacts. So for example, advanced grammar analysis, what this could do is this could improve search and educational NLP. So like, for example, let's say you're a non-native speaker of English and you want grammatical error correction to make your writing more lucid or other things like this. However, grammar correction can enforce prescriptive linguistic norms. So it may be something that you're writing that would be perfectly acceptable in your community might be marked as wrong just because it's not the way the majority of people use language. And just to give an example of how I've experienced this a whole lot, I speak almost like quote unquote standard American English. It's the American English that is very similar to like a lot of newspapers or something like this. Yes, and I was about to get to that. Yeah, and so one thing is we should reconsider what do we mean by standard, and why do we think it's standard? And actually, people are moving away from the idea of a standard American English and calling it, for example, white aligned American English, because that's maybe more accurate. Bob was pointing out, I speak the Great Lakes dialect of American English, and Bob does as well. I don't know how many native English speakers there are here, but can anybody tell me what is like actually not completely standard about the way I'm speaking? Not completely like normal American English. So people from the Great Lakes speak more nasally, like I speak more through my nose than most people would from a lot of other places like the East Coast or California or something like that. So I have a dialect also, it's just one that's kind of, not widely recognized as a dialect. But anyway, in Japanese, I speak a dialect that's very obviously a dialect because I lived in Western Japan the entire time, which is not Tokyo. And one thing that frustrates me a lot is if you try to write a text or like a message in that dialect on your phone, it gets corrected into something that's not that dialect, not what you wanted to say. And I think, maybe a lot of people here have experienced this too. It's like a very standard way of saying something in your dialect, but then Google underlines it as being ungrammatical, or Google autocomplete tries to recommend something that's like not what you would be saying normally. So I think this is worth thinking about. I think it's worth thinking about even more now that, you know, writing assistants like autocomplete on Google and stuff like this. So there was a very good comment. Maybe CMU should stop taking GRE verbal and TOEFL scores then. I think this is reasonable, and I don't have a really strong argument against this. But Bob's raising his hand.
There's a legal requirement for TOEFL to get a visa, though.
Okay. Well, there's a legal, Bob says there's a legal requirement for TOEFL to get a visa, which, I mean, sure, maybe that's a bad legal requirement and we should fix that, but.
Well, very quickly, the rationale is that they want to make sure people are really going to be a student here. If you're going to be a student in an English-speaking university.
Yeah. So there's a rationale that if you're going to be a student in an English-speaking university, you should be able to communicate in English. So I see what you're saying here, and I think like this is a very valid argument, and it's an argument for. I think the point is that you need to be able to communicate and understand English, and if there is not. I'm trying to pick my words carefully because I see the argument here, but I think. You need to separate communicative functions from functions that are not important for communication. And I think you also need to be very careful that you're not talking about communication to like only the majority group. This is it's a very difficult question. It's kind of like the question of should we be doing assessment of accent for people who are being employed at call centers? And that's a very difficult question, right? Like maybe yes, because they couldn't do their job otherwise, but maybe no, because that's unfair to people who didn't grow up with a typical accent or didn't go to schooling that, you know, basically allowed them to learn how to mimic a standard or a expected accent from a very early age. So I think one interesting thing is for a lot of these things, there aren't right answers, and it's a very nuanced argument. And that's also a place for research. If any of the stuff that I mentioned here is important to you, like, as I mentioned, I love the paper from Dan Jarafsky that examined 100 years of bias in word embeddings. There's also another paper by his group. He does excellent work in this about the difference in how police officers speak to people from majority groups and minority groups. And they went in and they did an analysis of speech from body cams from police officers, and they demonstrated differences in how people speak. So like basically about the GRE and TOEFL argument, I think like maybe this was kind of a, you know, I don't know how seriously this was said, but I'd like to give a very serious answer that I think this is something we can think about, and it's also something we can contribute to as NLP people. Yeah, so another thing, stylometric analysis help discover, like one thing it can do is it can help discover provenance of historical documents. So for example, stylometric analysis identifies the author of a historical document, which can be very interesting from a research perspective, but it could also unmask anonymous political dissenters. And in fact, I've turned down projects on stylometric analysis because of this, like, you know, of this risk. I was worried about contributing to something like this. It wasn't sold to me as stylometric analysis. It was sold to me as unmasking people who don't want to be unmasked. And I was like, well, maybe I don't want to be doing that. So yeah, it's something to think about carefully. Another thing, text classification and information retrieval. It can help identify information of interest, but it could also aid people who are trying to censor like political dissent, for example. NLP can be used to identify fake reviews and news, but also to generate them. And this is becoming a big, you know, topic right now. And so these problems are very difficult to solve, but it's important to think about and acknowledge them and discuss them, which is why I'm devoting a whole class to these issues. And I'm happy to, like, as I said, most of these things are a nuanced argument. I'm happy to discuss more at the end of class or later. And then a final thing, also to give some context, I was working on about 10 years ago, I was working on persuasive dialogue, which is essentially dialogue that tries to persuade somebody to do something. In this particular case, we were working on dialogue that gradually guides somebody towards buying a product while also considering that they are happy at the end of the transaction. So like I was working on this and I was like, well, maybe that's okay. You know, we're trying to sell things to people. And we had a multitask, multi-objective optimization function that optimized for happiness, consumer happiness and profit. And then I started to get kind of nervous about this, which was like, well, but it's extremely easy to remove the final part of the objective function and set its weight to 0. And then you have a ruthlessly like profit optimizing dialogue system that could like trick people into buying the most expensive thing, regardless of whether they wanted to do that later. And so I stopped that line of research myself. You know, like other people are doing it now. And I think the framework for ethical thinking about NLP has advanced a lot in the past 5 years. But basically, like, while I was doing that research, I found this really nice book called the like Persuasive Technology about from a professor who was entirely thinking about technology that persuades people to do things. And basically, the outcome, this is a thing from a paper that that book cited, where it says the outcome is, if the outcome is intended and ethical, that's praiseworthy. That's a good thing, right? If the outcome is intended and unethical, that's obviously bad. You know, you're doing something unethical on purpose. So that's obviously bad. The things on the right are a little bit more difficult, right? Unintended, if it's unintended and reasonably predictable, if it's unethical, then, you know, you still should be like considered at least morally responsible, I think, for this. So it doesn't matter if I'm working, or it matters less if I'm working on the system and say, well, we have this objective and we added this, like, the consumer is happy other objective, and so it's fine. I think thinking a step further and saying, well, it's super easy to remove this objective and other people could use our methods to do something unethical, then you know, I still think that's a problem. However, like, don't beat yourself up too much, or like, you know, overthink things and not be able to do any positive work, I guess, because, you know, there might be unintended consequences from your paper. Just to give an example, there was a paper, or there's some work a little while ago that created a dialogue system that had a, you know, an ethical objective, but people turned around and were able to basically cause it to generate toxic content. And if that's the case, you know, like, if you've done a best effort to try to avoid making this happen, then I don't think you should be blamed too much. And you can go and try to rectify the issue, but, you know, don't beat yourself up over it too much. So yeah, that's the overall framework here. So actually, to give a example of persuasive technology, since I mentioned it, that I think is persuasive but intended and ethical, you can think about something like Duolingo, where Duolingo, if you've ever used it, how many people here have used it before? Okay, a lot of people. If you've ever used it before, it gives you these really annoying push notifications at 11 p.m. that you haven't finished your lesson for the day. And however, for me, they were very effective at making me do a lesson at 11:30 p.m. to maintain my streak. And because of that, I know Chinese a little bit better. And so, you know, that's persuasive, but it's helping you achieve a goal that you already wanted to achieve, which is like learning a language better, and it's making you, you know, fight against your willpower. So that might be an example. Yeah, so basically, like, that's what I have to say about the final stuff. I had one comment on Zoom, which is the phrase reasonably predictable seems to be doing a lot of heavy lifting and could be a source of disagreement between domain and legal experts. I completely agree with that. Yeah, and so you can read the book Persuasive Technology for a lot more nuance on this argument, and I think it's in shades of gray as opposed to, you know, black and white, just like everything is. But I still think that, you know, this graph is useful. Yeah.
Well, in fact,
To-
reasonably predictable comes up a lot in legal circumstances. I mean, you do something, someone gets hurt, you
Mhm.
know, should you have realized that?
Okay,
Yeah.
that's a really good point that I didn't know. And Bob pointed out that reasonably predictable actually comes up a lot in legal, like, terminology as well. And then I guess you argue in court whether it was
If you
reasonably
put broken
predictable.
glass in the oatmeal, you're in trouble. If you put something in oatmeal that you think is harmless, but like makes someone sick, you know.
So if you put glass in oatmeal, it might make you'll get in trouble. But if you put something reasonable in oatmeal and then people get sick later, then yeah, depends how reasonably predictable it was, I guess. Cool. Any final comments or discussion or things like this? Okay, well, thank you for listening. I think this is super important to think about, like, now in 2022 more than ever. So happy to have any other discussion later.